Okay, this video we're getting into how to do labs really and how to make accurate measurements, how to represent your data in a way that reflects how accurate the measurements were. And so that's this, we have a really simple activity. I want to set it up here with this video and then have you try this in your groups. What I've given you for this, and then the material for the activity will be these glug rulers I gave you. I've cut them into separate pieces, which you'll need to do. So I've given you this. What is a glug? It's just a unit of length that I've made up. Of course, unit of length, the most common ones here in the United States, we use feet or inches or yards. Originally it was based on the length of a foot. But the scientific community and internationally, just about everywhere other than the US, uses the metric system, and the unit of length is 1 meter. Where did a meter come from? So of course the feet comes from the length of a foot, but feet are all different. So they said, well, let's come up with a standard one. At the time in Europe, they were just using all kinds of units for length. And so what they did is they said, well, they came after a lot of argument, they came to the agreement that they said, well, let's say we're going to make 1 meter the length of 1/10,000,000th of the length from the equator to the North Pole, which was hard at the time for them to measure, but they came up with it, and that's the meter that exists today. We're in this class after this activity, we're all into centimeters, millimeters, meters, kilometers. So we are into the metric system purely. But for now, let's work with glugs. And so I gave you 3 different rulers. And so let's say I want to measure the length of a pencil. I'm going to measure the length of this pencil in glugs. If I were to try, and I'm going to use this just 1 glug ruler, and I were to measure it, and I can see, well, this pencil is definitely less than 1 glug, but it's more than, of course, 0. And I said, well, why would I use this? I really wouldn't, but to get into when we're measuring using our equipment, we estimate 1 digit. So instead of saying, oh, it looks like it's about, I could actually estimate it's like 0.8. So this glug ruler tells me something about the length. It says that it is right around 0.8 glugs. So it's about 0.8 glugs. Notice the 0 is just there. So really it's 1, it gives me 1 digit accuracy of representation. Not very accurate. What I can't do, so what we do is, so I knew for sure it was between 0 and 1 glugs. So I can estimate 1 digit, and you'll see the importance of that in a second. So 1 digit. What I can't do is say, well, I think it's like 3/4 of the way there. And so 3/4 is 0.75. But what I've done is I know that it's between 0 and 1, but I don't know that 0.7. So I've actually estimated 2 digits here, and the number of digits represents accuracy. Cannot do that, right? Estimate 1 digit and 1 digit only. All right, so I want more than 1 digit. Normally in our measurements, we're going to want, if we can get it, at least 3 digits. Sometimes we'll get more than 3, but at least 3. So let's try this one. This one is my ruler that has to 1/10 of a glug. And I measure my pencil. And I was pretty close with my 0.8. So it's a little short of 0.8, and I'm going to go with 0.78. .78 glugs. So I had it to the 10th. What I knew is, I knew it was between 0.7 and 0.8. That was a given. That's my estimate, right? So I'm estimating 1 digit, 0.78 glugs. That number, so going from here to here, that says, hey, I must have used some more accurate equipment. I've got a little bit better feel for just how long the pencil is. Now let's go to this one. So, but still, that's 2 digits of accuracy in my measurement. Let's go to this glug ruler. And now I have to be a little more careful, go like, I'm going to start at the middle of that line, and 0.78 was a pretty good estimate. I think it's barely past, maybe it might be right on the line. So 0.78, and is it right on the line or just past? I'm gonna say just past, like 1.781, barely past the line. Well, notice what I have now by using that more accurate. It had the one ruler I used was it had markings to 100th of a glug, right? 0.78. That was given to me by the ruler. Here is my 1 unit of estimate. That gives me 3 digits in the number, and that number, the fact that I see this number, it says, hey, that was using more accurate equipment than this. This is kind of a lot of just estimate. I don't know very much about the length of it. More accurate equipment, more digits in my number represents more accuracy. It represents accuracy. And before we leave this number, what if, when I looked at it, because it was pretty close, what if I say, no, it really wasn't past. It was dead on that 0.78 line. And I said, no, it's 0.78. But that's not telling me that I'm using some from here to here. I actually used a different, more accurate. I have more confidence in that number. So if I say it's dead on 0.78, I would put that 0. So this 0 that we had here doesn't mean anything, but that 0 does. If it's in an accurate measurement, or we're representing measurements properly in chemistry, that 0 is my estimate. I think it was dead on 0.78. So that still is 3 digits, even though that's a 0 right there. That says something about the accuracy. So estimate 1 digit when we're making measurements. That gives me more accuracy, and we'll be able to use that when we're making our calculations for it. So 0.780 is 3 digits of accuracy. Okay, so in order to get 3 digits, for the pencil, I needed to use my one with markings to 100th of a glug. Sometimes it's not that necessary. If I'm dealing with a longer length, so I measured the height of my ring stand, and I knew I wanted 3 digits. And I said, well, okay, this is definitely more than 1 glug. And I measured it. I've already measured this and kind of marked off. So I measured from here. And then when you're doing this thing, if you want to bend to the edge so you can go from one to the other, or so you can kind of go end to end, one here, and then I went here, and I've already marked it and done this. I'm just going through quickly. And I said, well, it's like 2.47 glugs high. So that ring stand, 2.4, and I estimated 7. That's my estimate. So it is 2.47 glugs high. That gives me the number of digits I wanted. I wanted it to, and in your activity, let's get at least 3 digits. That won't always be the case in every lab. But if I were saying, let's get at least 3 digits, I can get away with using the glug ruler that only has the 10th, because now, look, I have this digit here. Before there was no digit here. Now I have a digit here, 2.47. And so I don't need, when I'm going to a longer length, I don't need something that gets me to the thousands. Let's see. Could I ever use this one? Would it ever be appropriate to use this glug ruler, 1 glug ruler? Sure. What if I want to measure? I'll have to go off camera. I've got this big whiteboard in my room, so I'm going to come over here and start and go and go and go. And now I'm on the camera, and I could keep going, right? And with this guy, and I did it just in a quick fashion, and I found that it is 14.3 glugs wide. So in that case, if I'm doing long enough length, 1, 2, 3, 3 digits in my answer, I could get away with the 10th glug ruler. If I were dealing long lengths, I could take a bunch of these, make copies of them or something, and tape them all together like a tape measure, and I could measure with this ruler and get plenty of accuracy for most uses. Okay, let's look at calculations with this. I have a whiteboard similar to the whiteboards that your group's got, the bigger ones. And I took my glug ruler already and I measured it. And I said, well, in the length of this thing, or the biggest length, 3.31 glugs long. And I measured it this way, and 2.48 glugs wide. So I want to find the area. How many square glugs of area in this whiteboard? And so it was, of course, length times width. Area is length times width, 3.31 times 2.48. Now when I did that on my calculator, it came out with the number, and so I plugged in the calculator, 8.2088 square glugs. That's what the calculator said. However, what that number, we just talked about how the number of digits in a measurement or in the answer says something about the accuracy of the equipment used. How reliable are those measurements in terms of accuracy? This number, if I left it like that, would be a misrepresentation of how accurate the equipment was that I used. I mean, I used, a glove wheel to do it. So that says, that would be like if I used super precision equipment, laser measurement type stuff, and I didn't. So what do? When we're multiplying or we're dividing, our next lab that coming up is density. Density is the mass divided by the volume. If I'm multiplying or dividing, I take the numbers in my answer and the ones with the least digits, and I round to that same number of digits. Both of my length and width were in 3 digits of accuracy, so my answer has to be rounded to 3 digits. 1, 2, 3, and then of course, because this is an 8, I'm going to round up. 8.21 glugs. Now that number tells me, okay, because my measurements were in 3 digits, I round to 3 digits, and so this is giving me an idea of just how accurate that was. And so we have some practice with that in area, using that in this activity. The next video is going to be using what we call significant figures and really working with this stuff a little bit more with the calculations. When are zeros significant, and when are they not significant in a number? So when I had this 0.78, we said, well, that one doesn't count. So when do zeros count and when do they not? That's the next video. Even though this is a kind of a short, simple activity, I do want you to do it in groups. Part of what we're going to do and part of what we're trying here is that discussion within your groups and talking about it, making sure everyone's got it, and you explaining it to someone else. That really helps with our understanding. Right now, the class starts really easy with some of these early activities, but it gets a little more challenging. So we really want to get those groups working together strongly, working well, and then we're going to be set up for what we got later on in the class. So that's it for this video, then significant figures next, and we'll see how it goes.